hi. My name is Jonathan James Chavez, and I'm going to introduce a team which consists of Britney, Ibarra, and Daniela Cortes. So we did a, a machine of Goldberg, and basically we're gonna explain how it works with the different movements that we can see in the machine. So we can see like free fall, we can see vertical shot, we can see parabolic shots, we can see ULM, we can also see MCA. So we see a lot of movements. So we're gonna explain how we can see them in the machine through the video, and we're also going to explain how they work. Like if they have vertical motion, horizontal motion. Also, we'll see how the laws of Newton apply this, and the vectors, and the system of units. So I hope you enjoy it. Thanks.
Yeah.
Here the object is experiencing from HPM, horizontal projectile motion. This is happening because the object is moving while it's also falling. That's why it's called HPM. And this movement has ULM and free fall. Here the object is suffering from CPM, complete projectile motion. This happens because the object continues moving, will go with a vertical launch, and then will suffer from a fall. That will be free fall.
Okay, so right here we can first see a rate of free fall because when the ball falls, it goes down and hits the kid, he reacts, and then he shots. And this is a kind of projectile motion because the bullet goes out of the canyon like a really high speed and a really small rate. It will deaccelerate, so we'll lose speed, but very, very slowly. And then finally we hit the ball, and we can see also MCA here because the ball will eventually run out of speed, the velocity will go down at a very, very slow rate as well. But yeah.
Okay, so here we can see an example of ULM, or uniform linear motion. A motion in physics is defined as the change with the time of the position or orientation of a body. So here we can see that is a uniform linear motion. That the definition is that is a type of motion defined as the motion of an object in which the object travels in a straight line and its velocity remains constant along the line, as it covers equal distance in equal intervals of time, irrespective of the duration of time. So here we can, we know that is uniform linear motion because here we can see that this is a straight line. All the pieces were like at the same distance, and when the first piece falls, all the pieces falls at the same time. And if we continue like here with more and more pieces, it will continue with a constant velocity. And okay, yeah.
In this case, we are applying the Newton's second law, which expressed that everything that goes upwards must go downwards. And this is happening due to gravity.
Okay, so in here we can see the third law of Newton, which is the law of action and reaction. So when the bullet hits the ball goes right, and the bullet it will go the opposite direction because of the reaction. So we'll go to the left.
Okay, so here we can see that the last piece will hit this object and the object will fall like this. Okay, so we can say that this is free fall. That free fall in physics means
uh, is any motion of a body where gravity is the only force acting upon it. In the context of general relativity, where gravitation is reduced to a space-time curvature, a body in free fall has no force acting on it.
so. Here we can see that this object don't have like here there is no like a lot of resistance and all of that, so we can say that the object falls and so is free fall. And this we can relate it with Newton's first law, because in the Newton's first law he explained that every object will remain at rest in or in uniform motion in a straight line unless compelled to change its state by the action of an external force. So here we can see that if we like put the object here, it will rest until another force like acts, and that's why the object will fall.
So, in this case, I believe that this machine was helpful to let us see the kind of movements that exist and how can we apply the Newton's law on it. I believe that thanks to this type of movements, we are able to create lots of more professional machines that help us on our daily life, and it helps us to see and be able to acknowledge how can physics be useful in our daily life. Thank you.
Okay, so this project really got us to think um how the what we learned in class could be applied in real life, and we get to see different kinds of forces in real life and actually think about them. So yeah, actually, and now also something that I really like is that almost all of the things we learn, if we actually get the measures of everything and like the time and stuff, we could actually like get the velocity, um the acceleration, and now we know about the gravity and stuff like that. Actually, also with the laws of Newton, we know that there is uh inertia, friction, and everything is acting upon every single item. So I think that's what's important about physics. Like you learn that it's always a force in everything. So yeah, I think that's something really cool.
Okay, so in conclusion, I think this project was very, very interesting because we can see like all the things that we saw in this partial, like unilinear motion, MCA, everything, projectile motion, like in a few minutes. So I think you can realize that there we use like physics in everything in our daily life, in like simple things we are like using physics. So I think that is very interesting, and it was cool like to see all of that like in a short video or in a machine.